Hello and welcome to this video on force. Very important topic and very common topic of physics. When you think of physics, the first thing that comes to your mind is force. You're going to study about force in physics. Alright? And the other thing that comes to your mind is Newton. So Newton's laws of motion will cover all these things in this chapter very nicely. If you are scared of what Newton's laws of motion are, watch these videos. It will clarify all your doubts, right? So let us start by understanding what is force. This is our video number 1, and in video number 2 we'll be taking up Newton's first and second law of motion. Before we start understanding Newton's first and second law, it is very important that we understand what is force, right? So this is our video on force. So first question, what is force? So if we think about defining force in a particular definition, there can be so many ways in which you can speak about or define force. So defining force as a definition generally is not an exam question, right? So you feel force. You feel force. How do you feel force? As a push or a pull. When you push or a pull, you feel force, right? Changing speed. Force can change your speed. If you're moving already, say somebody pushed you from behind, you change your speed. You move at a higher speed. If you're already moving, somebody pushes you from the front, you fall back. Your speed changes, as well as your direction can also change. Force is something which can push, pull, it can change speed, it can change direction, and as you know, it can squash, it can expand, it can break things, it can crumble things, etc., etc., and etc. So many forces you would have heard about: gravitational force, then your force of friction, air resistance, right? The force in the spring, the force in a elastic band. So there are different kinds of forces, right? We'll be understanding everything in physics, but this chapter is about the basics. What is force? Force is a vector quantity. What does it mean? It has a magnitude and a direction. If you want to talk about force, you have to not just tell its magnitude, you have to also tell its direction. This is what the first point is saying. Say for example, if you're saying that the force is 5 newtons, that's just not enough when you talk about force, because you are just giving the magnitude. You have to also give the direction. You have to mention, say it is in the right direction. All right? Or if the force is acting upward, then you say 5 newtons upward. So you have to mention both the magnitude and the direction if you want to clearly specify, show your force in your answer, right? All right. So how do you represent force? That's your second point. It is represented by an arrow. Now arrow, if you look at arrow, it has two parts. The arrow has a body, which is the length, and it has a head, right? So what is the length of the arrow represents? The length of the arrow represents the magnitude. It is proportional to the magnitude. And the arrowhead, its direction is same as the direction of the arrow, right? So if the force is represented by an arrow, the two parts of the arrows, the length of the arrow represents the magnitude, and the arrowhead represents its direction. Let us understand the magnitude part of the force. Let us suppose that you are drawing a force of 5 newtons like this. This is your 5 newtons. If you have to represent a force of 10 newtons, how long the arrow should be? Twice this length. This is your 10 newtons. This is what it means. The length is proportional to the magnitude, right? If you are drawing a force of 2.5 newtons, it should be half of this length, right? This is a 2.5 newtons. If you're drawing an opposite force of 5 newtons, how would it look like? Opposite force, like this. This is 5 newtons in the opposite direction as the first force that we had drawn here, right? So very, very important thing, force is a vector quantity. The length of the arrow which represents the force is proportional to its magnitude, and the arrowhead represents the direction of the force. Simple thing, one of the most basic things that you should be clear about before you start understanding force. Alright, so let's talk about resultant force. It is a single force that has the same effect as all the forces acting on the object. Say that there are multiple forces acting on this object. What is the object that you see here? You see a box which is lying on the floor, right? So let us apply some forces on this object. Say that you're applying one force like this, which is say 10 newtons, and another force also same in the same direction, say this is 5 newtons. So what is the resultant force? What is the resultant force? It is a single force that has the same effect as all the forces acting on the object. So what is the resultant? Because both the forces are applied in the same direction, the resultant is the sum of the two forces, right? So this is the cream arrow is your resultant, 15 newtons. This is your resultant force. Let's call it RF, resultant force. All right, resultant force is 15 newtons. What does it mean? If there are say two people pushing on the box, one person is applying a force of 10 newtons, the other person is applying a force of 5 newtons, right? If you add them up, which is 15 newtons, say that there is another person whose strength is same as the sum of the strength of these two people combined together. So if you have this stronger person applying the force, he'll be applying a force of 15 newtons, which is the sum of forces of the individual people here. So this one person, strong person, which is 15 newtons, is same as two people which are 10 and 5 newtons, right? So the resultant of the forces when they are in the same direction is the sum. It is pretty logical also, because you're applying all the forces in the same direction, you're adding up all the forces that are applied in the same direction. Let us take another scenario where the forces are not in the same direction. Say one person is pushing on this box from one side at 10 newtons, and there is another person, say a smaller person, pushing from the other side with a force of 5 newtons, right? There is a big person here pushing with a bigger force, a small person half the size pushing with the force of 5 newtons. So what is the resultant force? The resultant force is, think about it, because the forces are in the opposite direction, the resultant force is 5 newtons. How do you get the resultant? You subtract the forces, right? Because they are in the opposite direction. The box will move. Ultimately, the box will move, right? But in which direction will the box move? The box will move in the direction of the bigger force. So this is your resultant force. How do you get it? 10 minus 5, which is 5 newtons. So when you have to find the resultant, always look at the direction of the forces. If they are acting in the same direction, the resultant is the sum. If the forces are acting in the opposite direction, then the resultant is the subtraction. Let me complicate this whole scenario slightly more. Say that one more small baby has come from this side and he is also applying a force. He is applying a force of, say, 2 newtons. So how much is the resultant now? Think about it. What is the resultant? Total force towards the left, 7. Total force towards the left, they combined together, they are 7. And the total force towards the right, you know, is 10. Right? So the resultant would be 10 minus 7, which is 3 newtons. In which direction? The resultant is always in the direction of the bigger force. So it is towards the right. Alright. So this is your resultant. 3 newtons. 3 newtons towards the right. Alright. So this was all about when the forces are in the straight line, whether they are in the same direction or they are in the opposite direction, but they are in the same parallel line. Right? Sometimes the forces can also act in very random ways. Right? Say, to give you an example, say one force is acting this way, other force is acting this way. They are not in straight line, they are not parallel line. Then you have other force acting this way, one other force acting this way. Then finding the resultant is not so simple because you cannot simply add or subtract the forces here. Forces are vector quantities. Then you need to use some understanding of your maths, which we'll cover in a later chapter. So if this is the scenario when multiple forces are acting from random up, down, different directions, addition of the vector is done using Parallelogram Rule of vector addition. There is a separate video for it. You can check it out. That also is very easy, right? So far we'll concentrate on finding the resultant. Finding the resultant when the forces are in the same direction. Error number 5 here. When the forces are in the, so far we are interested in finding the resultant when the forces are in the same straight line, as in like this, like this. They are parallel lines, right? All these lines, if you see, they are parallel lines. So here it is easy. When the forces are in the same direction, you add them. When the forces are in the opposite direction, you subtract them. Alright? Now the next thing to understand is balanced forces. What is balanced forces? When the resultant force is 0. Simple. Say that this is a box. 2 people are pushing from, or maybe this time let's take 2 people are pulling the box, right? One person is pulling the box from this side with a force of 20 newtons. Another person is pulling on the other side with a force of 20 newtons. Both the people, both the person who are pulling on the box, they have the same strength, they are applying the same force. Will the box move? The box will not move because equal forces are acting in the opposite direction. So how much is the resultant? How much is the resultant force? Because the forces are in opposite direction, how do you find the resultant? You subtract the forces, right? So 20 minus 20 is equal to 0 newtons. So effectively, this is a case of zero force acting on the box. When zero force acts on an object, will the object ever move? No. Same thing is happening here. Though there are 2 forces visible here, but the effective result is that there is no force. This is an example of resultant force being 0. This happens in the game of tug of war. If you would have experience watching such sport, 2 teams pulling from the 2 sides, if the 2 teams have the same strength, then the game is a draw, right? Because the force by one of the team is exactly equal and opposite to the force by the other team. So you have a draw. Why? Because the resultant force becomes 0. Alright, so resultant force being 0, not a very difficult thing to understand. Alright, so let's move on. Here we have an example. Suppose one team pulls with a force of 1000 Newton and other team pulls with a force of 750 Newtons. How do you draw the force diagram? So what teams are we talking about? We are talking about the teams of tug of war. So how do you draw the forces? You can pause the video for a while, draw your diagram, come back and pause again. Two forces, 1000 Newtons and 750 Newtons. Please do remember you have to draw the arrows with the magnitude proportional to the length of the arrows. So let's see how the answer would look like. So force of 1000, if you see, is a longer arrow. The black arrow is your force of 1000 Newtons. The other black arrow is a force of 750 Newtons. This arrow is 3/4 the size of this other black arrow. 3/4 the size. What is the resultant? Because the forces are in the opposite direction, the resultant is 270 Newtons. Sorry, the resultant is 250 Newtons and its direction is same as the direction of the wake-up force. This is your resultant force, right? So this video was about the basic understanding of some of the things that you should know about forces. So this is where we end this chapter. This was a short chapter on some of the basic stuff that you should know about forces. And these were not difficult to understand, but they are very, very important thing for you to understand, right? So the next chapter will be on understanding Newton's first and the second law of motion.